Welcome back, Warhawks. Today we are going to do chapter 11-2, talking about angle measures in a circle. Some of this is going to be difficult, some of it's going to be somewhat seem easy, but hopefully we'll get through this together. Pay attention, I'll try to make this as quick as possible. Central angles and arcs. So angle measurements in a circle, we have a relationship between central angles, like angle B, and the arc that goes with it, like arc AC. A central angle degree measure and a corresponding arc degree measure are equal. So if we have a situation like this where we see that angle ABC is 110 and it's right in the middle there, it's a central angle, this arc is actually going to be equal to the measure of the degrees of the central angle. So that seems like it's pretty easy. Okay. And to be honest with you, it is kind of easy. Let's look at a couple more examples here. So let's say that we had a 60-degree arc right here. Well, what would the measure of that central angle be? Well, they have a relationship. Let's look back. The degree measure of an arc and the central angle share the same measurement. So, well, 60 is probably a bad example to use there. It's not really 60 degrees. Let's say it's like 30 degrees. Well, what's the measurement of that central angle going to be? Well, it's also going to be equal to 30 degrees. Here we have a central angle that's 90 degrees, and we want to know what the angle measurement or the degree measurement of the arc is. Well, it's equal to the central angle, so it's also going to equal 90 degrees. Now, this is a little bit more of a complicated example. What we're going to want here is actually this whole arc measurement here. Okay, that whole arc. They're going to tell us that this is an 80-degree angle. And this is, we'll say, a 25-degree angle. And they want to know what the measurement is of that whole arc. Well, if we look at it, the arc, those two arcs added together make the whole arc. This is 25, I know that. This is 80. So together, the whole arc there would actually equal 105 degrees. So far, so good. Hopefully, this part is easy. Now let's look at some different examples. So now we get to a difference. Now we're talking about inscribed angles and arcs. An inscribed angle is an angle with its endpoint actually on, or its vertex actually on the circle. Okay, so it's a little different. Look back here. This is a central angle. This is an inscribed angle. So an inscribed angle, its measure is equal to half, very important there, the degree measure of the corresponding arc. So if in this example we said that this was, we'll say that it's 80 degrees here. Well, what would this be? Well, think about it. The inscribed angles measure, which is the question mark, is equal to half of the measurement of the corresponding arc. So if this is 80, you may have guessed it already, but this would be 40 degrees. It's equal to half. Let's look at another example here. So on this one, I'm going to go backwards. I'm going to say that this is a 95-degree angle, and I want to know what the measurement is of this arc right here in degrees. Well, remember, the inscribed angle is half of the corresponding arc. So in this case, we would double that, which would be 190, and that's going to be the measure of that corresponding arc there, and that would actually be a major arc because it's more than 180. Let's look at one more example. If let's say that this were 25 degrees, what would the measurement of that arc be? Well, the inscribed angle is half of the arc, so 25 times 2, the arc angle is going to be 50. Now, these were mostly easy case scenarios. Let's look at some harder case scenarios. So these are pictures that they'll sometimes give you. They may give you a question mark here, a variable there, and a variable here. Now let's really look at this example. The one thing I'm going to give you here is this measurement. I'm going to say that this measurement is 70 degrees. They want us to find both of these measurements here. Let's think about this. First of all, the arc's probably the easier one to find. This arc right here. So we know that central angles are equal to their arc. This is a central angle, so the arc's measurement is going to be 70. But now we're combining those two things together to find two answers. If we take out this part in the middle, see, we can see that we're actually left with an inscribed angle. And the measurement of the inscribed angle here is going to be equal to half the measure of the corresponding arc. So this arc's 70. What would the inscribed angle be? It's going to be half of that, or 35 degrees. Okay, notice what happened there. We had a central angle, we used it to find the arc's measurement, and then we used that arc to find the inscribed angle. These are questions that they like to ask as well. So here's a hard case scenario. We've got this arc measurement right here. We want to find out what this is, and we want to find out what this is right there. We'll notice something. If I take out this and this, I'm left with an inscribed angle. I have the corresponding arc. So this measurement is going to be equal to half of the corresponding arc because it's an inscribed angle. It'll be 20 degrees. Now let's put back in these measurements here, or these chords, I guess I should say here. And look what else we have. Now let's take these out. And look what we're left with. Another inscribed angle that uses this exact same arc. So guess what this one is also going to be? 20 degrees. These are questions that they really like to ask. So if we look at this again, notice how these two inscribed angles share these two endpoints right here that go with this arc. So if this arc's 40, both of those are actually going to be 20 degrees. That's a tough question. Let's look at our last example here. Now this is going to be the center of my circle. Okay. The only thing they're going to give me is they're going to give me that this angle right here is equal to 80 degrees. And actually it's not an angle, it's an arc. So this arc is 80 right here. So a couple things that we need to notice about this picture. First of all, we do have an inscribed angle here that goes along with this arc that's 80. If we take out this, we can really see that this is an inscribed angle with an arc angle that's 80, or arc measurement that's 80. So this inscribed angle will be half of that arc. So the inscribed angle is going to be 40 degrees. Let's put this back in. Okay, so in this you're going to have to do some manipulation with your mind to be able to kind of see through some of the stuff that's extra in there. Now here's another question. This is all the information we have, but we actually want to be able to find all of these angles. Let's think about how we're going to do that. What's special about this line? Well, this line is a diameter. A diameter splits a circle into two equal parts. So this whole arc right here is going to be 180 degrees. It's half of a circle. Okay? So if with my mind I can remove this line, I can see that this is an inscribed angle that goes with the diameter. So it's half of 180, which means that that angle right there is going to be a 90-degree angle. And then lastly, I want to be able to figure out what this is. Well, we don't have this part right here, but look what we do have. This is another semicircle. So altogether, it has to equal 180. Well, if this part's 80, that means this part over here is going to be 100 degrees. This is an inscribed angle with that 100 degrees. If I remove this, I can see how that angle is inscribed with the 100-degree arc. So that angle is going to equal half of the 100 degrees, or 50. Notice something here. When I add my arcs, all of them together, what measurement should I get? I should get 360 degrees, because that is the degrees of a whole circle. I have 180 plus 100 is 280 plus another 80 is 360. The whole circle should equal 360. Now this shape right here is a triangle. Triangles always sum to equal 180. 90 plus 50 is 140 plus 40 equals 180. So that's kind of a way you can check your answers. I hope you enjoyed it. We'll see you in class.